video is for 6.5 Arithmetic Sequence. As we already mentioned in class, first of all, let's see what is a sequence. Now, sequence is list of numbers, right? Now, each number is called a term. And there's a first term, second term, third term, and so on. Now, here also mentioned about a sequence can be finite, means they have certain amount of number in it. So you can count how many terms are in the sequence. Or it could be infinite. That just continues forever. Now, for example, in this one is only 4 terms in the sequence. Now, 1, 3, 6, 10, it goes on forever until you can either imagine or even lose your imagination. So then this is called infinite sequence. Now, the 3 dots is used to express the ongoing process. Now, it's very important to differentiate what is a term in the sequence or what is a term number. So this is called a subscript. The subscript defines where this term is in the position of this term in the sequence. Now, for example, if the subscript is 2, then we understand this is a second term. But then A2, it is a term value. So very important that we do not, mess up with what is the second term, which is a term number, the second term, the third term, or what is the value of the term, which is what is the second term, how much is the second term, what number is in the second term of this list of the numbers. So now as we look at this, A1, A2, A3, all the way to AN, using called the set notation, we can write entire sequence is AN, means it's all the way from A1 to AN is a list of the numbers. Now another thing is, let's pay a little bit of detailed attention to this. So finite, the finite, we write it from 1, 2, 3, all the way to n. So this is just consecutive whole numbers or consecutive natural numbers. It goes on forever. However, it does have the ending. Depends on how much n you want n to be. You want n to be 355. That means there's 355 terms in the sequence. But if it's an infinite, then you get 3 dots here. That means this is a go on forever. And we cannot really define how many terms are there in this sequence because they got infinite number of terms. Now, just a couple of examples here to just show you, especially what is the difference between a term number and also the term value. Now, for example, AN means each term is made of this n plus 1 divided by n. Now, n now it is a term number. AN is a term value. So therefore, if it's A1, then that means the n here is 1, so 1 plus 1, and the bottom is still n. So therefore, that is 2 over 1. So that is 2. Now, what is A2 here then? A2 is, then this n is 2. 2 plus 1 and divided by 2. So then that is 3 over 2. So you see, this is first term, this is second term, then you can go on to do your third term and fourth term. It's just a little bit tedious, but also when you read the textbook, please also just try these two by yourself. All right, so the sigma notation, I have no idea why the sigma notation has to be in this section. So we leave the sigma notation to next section. All right, so now in the class, we tried to prove this is the formula. So arithmetic sequence, as far as arithmetic, we talked about if the sequence is arithmetic, that means there is a common difference. That means between the two consecutive terms, the D, they have a common, it's D. The difference is always the same. All right, so now in this case, I always disagree with using the Tn. So I always will be using the An. So it means any term value is by this formula. And we proved in class, all right? So this first A is A1. So any of them, as far as you know, the position of this term, then you shall be able to calculate how much this term should be. Now, for example, take a look at 3, 5, 7, 9. So look at this. First of all, we know the common difference is 2. All right. So then in this case, I can do anything. So if you ask me A20, then I can just say, well, the first A1 is 3. And A20, so n minus 1 is 20 minus 1 multiplied by 2. And here is 3 plus 19 multiplied by 2, which gives me 38. So plus 38, then this is 41. All right. So now here they ask you common difference, then you should be able to definitely see the common difference. Now this one, the common difference is -3. So if the common difference is -3, then that means it's decreasing in the sequence. Now if it's a +2, then you understand the sequence is going, every single number is increases. All right, so let's take a look at another question, example. So example just as I demonstrated above. Now take a look at here. We know the common difference is 3, and then we know A1 is 2, and you basically just plug the number in. So if it says A12, that means A12, and that is the first term, and 12 subtract 1 multiplied by the common difference, and 35. All right. Now they can also ask you, what is a term number? You know the term value, now what is a term number? So now here again, we know the common difference is 3. So then we do not know the term number. So we're trying to figure out what is the n here. So then the an, the value is given. So then that is 439. That equals to A1 again is 4 plus, we don't now know the n. We're trying to calculate the n. n minus 1 multiply d. d is 3. So this section, if you realize, this is just solving. This is basically solve for linear equations again. As soon as you understand the definition of arithmetic sequence, whatever the task you are, you're basically just solving. So now here, of course, you should be fairly fluent by now. Move this 4 to the other side. That becomes 435. And then this becomes 3n. Subtract 3. And move this one to the other side. Now it's become 438 equals to 3n. And divided by 3, divided by 3. And now n equals to 146. Oh, what's happening here? I just did something to get something wacko. So let's see. Draw again. See whether I can correct this. Okay. All right. So then let's see. Okay. So n equals to 146. Uh-oh, what's going on here? I needed to draw it. And here we go. Here we go. 146. Okay. Your textbook does something, as a matter of fact, this is quicker and smarter. So you don't have to multiply by this scene, multiply by this scene. After you move the 4 to the other side, now you just have this 3 and subtract to 1, and then you just divided the 3 first, and then move the 1 to the other side. All right. And now here we got two variables, and then we have to find the have two equations to solve for two variables. So what's going on here? It says the 7th term, so that means it's A7. That equals to 78. Now also says the 18th term, which is A18. Now this is 45. Now first of all, from here you can see this is a decreasing. This is a decreasing sequence, then your D will be a negative number. So then asked to say what is the first term? So in this case we can write this out. So A7 should be A1 plus 6D, right? Because a 7 subtract a 1 is 6D. Now A18, then that is should be A1 plus 17D, because it's again n minus 1 is 18 minus 1 is 17D. So now we do know A7. How much is A7? 78. We also do know what is A18. A18 is 45. So now we got the two equations. 78 equals to A1 plus 6D. 45 equals to A1 plus 17D. What is our variable? Variable is A1 and D. So in this case, we have two equations to solve. So this is our first equation, and this is our second equation. All right. So in this case, pretty easy. You have practiced how to solve for these two equations. So in this case, first of all, it's much easier just to use the 1 to subtract the 2. So in this case, that means 78 subtract 45, and that is 35. No, what am I talking about? 33. And then equals to A1, subtract A1, that's 0. 60 subtract 70, 17D, then that is negative 11D. So therefore, D equals to negative 3. So then plug this back into one of the equations, then you will get your A1. Okay. This is a little bit too tedious for me just to talk like this. So what you can do is that you can do to read this question by yourself. But okay, I demonstrate because I do not do your textbook's way. I do my way. So my way to solve this one is their consecutive terms. So consecutive terms means this is the first term, and then this is second term, and this is third term. Or this is a 4, and this is a 5, and there's 6. We understand what consecutive means. So that means, and then their arithmetic sequence. That means this one subtract this one should equal to this one subtract that one, because there's a common difference. They're the same. So therefore, 2x subtract 3, this is my second term. That is minus my first term, 3x plus 2. Now this should be equals to my third term, subtract the second term. So then that is 2 subtract 4x. Now subtract my second term is 2x minus 3. and then open them up, clean them, organize them, and then you will find out x equals to 2. All right, so then x equal to 2, then plus x in here, then you got your sequence. The first is 8, the second is 1, and the negative 6. All right, okay, well then enjoy these questions in the exercise set. Thank you for watching.